onward to reflecting. The first part, we're looking at reflecting about the x-axis. Just want to have you understand what this means, just so that you could understand that x-axis is the horizontal axis. And when you reflect about the x-axis, it's like you take the mirror image on the other side of the x-axis. So pretty much everything that's above the x-axis ends up reflecting below, and everything that's below the x-axis ends up reflecting above. So we could draw a quick little mini idea here. Again, it's the x-axis. So if you're above, wherever you're at, you reflect below, and if you're below, you reflect above. And if you're on the x-axis, you stay where you're at, because that's your point of reflection. So kind of like a mirror in a sense. And so when you're going through these, it's important to remember that you can visually do this if you have the abstract, but really what's happening is that when you reflect about the x, the y values will change. And we'll see this happening in terms of, it lets us know based on what the formula looks like. You'll notice that you see not only a constant being multiplied by your function, it's the fact that your constant is a negative. Or if it's already negative, it turns into a positive, but still means the same thing. Excuse me. Okay, so if you can keep that in mind, don't forget about the sign. Remember what f of x really means. F of x is the same thing as y. So what we really look at is they're really saying, oh yeah, it's like a negative times the y, hence why the y values change. So I like to do this visually, and then I'll show you the coordinate method just in case. But if I was to reflect this graph, all I'm doing is I'm going to change the signs of all the y values. This is what this is saying when you reflect. So you're reflecting about the x-axis, which means change the signs of all the y values. And because we have nice points where we actually see the y values, I'm going to look at my first coordinate, and I'll draw this on the graph, -4, -1. Now, if I'm going to reflect this upwards, it's below right now. If I'm going to reflect it, it has to be the same distance away from the x. So right now, it's 1 unit away. When I reflect it, it still has to be 1 unit away, so it reflects upward. So that's my new point. Now, same idea. The next point, -1, -2. If you're going to reflect this, it's 2 units away from the x-axis. So if you're going to reflect it, you have to reflect it upwards because it's already below. So you're going to reflect it 2 units above. So a little mirror image there. Next point, you notice that this is already above the x-axis, so it must reflect below. And when you reflect it, just kind of keep in mind it's 3 units away from the x-axis. So you'll also reflect it 3 units away from the x-axis, and that's your new point. One last one. We'll take this point. It's above the x-axis. It's only 1 unit above the x-axis. So when you reflect it, you got to reflect it downwards. It's going to reflect 1 unit below. So now if you connect your points, what you end up having is the actual reflection. So the graph did not shift, it did not stretch, it did not shrink, it just is a reflection. It's kind of like a flip-flop. So whatever happened here goes up, whatever happens here goes down. So anything above goes below, anything below goes above. Now if we want to make sure that we have our points, just to make sure we have -4, +1, we have our final draft, right? Always got to do that. -1, 2, 2, -3, and 4, -1. We'll just draw it and we're good to go. Try to be a little straighter, a little more careful there. So there's our reflected graph. And notice if you were to fold it along the x-axis, if you draw it on the same axis, they will be the mirror image. assuming you draw these as straight as possible. So if you understand that, you don't have to do the coordinate method, but it is nice to play with this so that you understand what's actually happening if you have to apply this to actual functions. So I have the coordinate method right here. I'm going to look at, again, just drawing the ordered pairs from my original function. So my original function, we've done this for the last few compressions and stretches, but I should have -4, -1, -1, -2, 2 and 3, that's this point, and 4 and 1. So we've been doing that already. Now, anytime you're changing the y values, usually you can say, well, that means that I can look at, just looking at what is the opposite of my y value. So I don't have to do anything special other than change the sign of whatever y values that you had already. So if you were -1, your new y value is going to be +1. If you were -2, your new y value is going to be +2. If you were +3, your y value is going to be -3. And if you were +1, your y value is going to be -1. So now when you look at your ordered pairs, just so that I can kind of show you, -4, +1, you guys see that right there. -1, 2, that's right here. 2, -3. We're looking good. And 4, -1. We've got our ordered pair. So whatever works nicer for you, feel free to use. I like to do more visual, but then sometimes at first it helps me understand the y values are being modified. So the entire function is being multiplied by a -1 in a sense.